Security professionals are often tasked with reviewing log files. But these files may have thousands of entries, so it can be helpful to automate this process. And that's where Python comes in. Let's start by importing a simple text file that just contains a few words and then storing it as a string in Python. All we need is the text file, its location, and the right Python keywords. We're going to start by typing a with statement. The keyword with handles errors and manages external resources. When using with, Python knows to automatically release resources that would otherwise keep our system busy until the program finishes running. It's often used in file handling to automatically close a file after reading it. To open files and then read them, we write a statement that begins with the keyword with. Then we use the open function. Open is a function that opens a file in Python. The first parameter is the name of the text file on your computer or a link to it on the internet. Depending on the Python environment, you might also need to include a path to this file. Remember to include the .txt extension in the file name. Now, let's discuss the second parameter. This parameter in the open function tells Python what we want to do with the file. In our case, we want to read a file, so we use the letter R between quotation marks. If we wanted to write to a file, we would replace this R with a W, but here we're focusing on reading. Finally, file is a variable that contains the file information as long as we're inside the with statement. Like with other types of statements, we end our with statement with a colon. The code that comes after the colon will tell Python what to do with the content of the file. Let's go into Python and use what we learned. We're ready to open a text file in Python. Now, we'll type our with statement. Next, we'll use Python's built-in read method. The read method converts files into strings. Now, let's go back to our with statement. Similar to a for loop, with statements start an indent on the next line. This tells Python that this code is happening inside the with statement. Inside of the statement, we're going to use the read function to turn our file into a string and store that inside a new variable. This new variable can be used outside of the with statement. So let's exit the with statement by removing the indentation and print the variable. Perfect. The string from the text prints out. Coming up, we're going to discuss parsing files, so we are equipped to handle security logs in the future. Now that you know how to import text files into Python, we're going to take this one step further and learn how to give them a structure. This will allow us to analyze them more easily. This process is often referred to as parsing. Parsing is the process of converting data into a more readable format. To do this, we're going to put together everything we learn about lists and strings and learn another method for working with strings in Python. The method we need is the split method. The split method converts a string into a list. It does this by separating the string based on a specified character, or if no argument is passed, every time it encounters a white space, it separates the string. So a split would convert the string we are learning about parsing into this list. We are using the split method to separate the strings into smaller chunks that we can analyze more easily than one big block of text. In this video, we'll work with an example of a security log where every line represents a new data point. Store these points in a list. We want to separate the text based on the new line. Python considers a new line to be a type of white space, so we can use the split method without passing an argument. We'll start with our code from the previous video. Remember, we used this code to open a file and then read it into a string. Now, let's split that string into a list using the split method and then print the output. After we run it, Python outputs a list of usernames instead of one big string of them. If we want to save this list, we would need to assign it to another variable. For example, we can call the variable usernames, and then we run it again. And now this list can be reused in other code. We're now going to bring all of the pieces together to import a file, parse it, and implement a simple algorithm to help us detect suspicious login attempts. In this video, we want to create a program that runs every time a new user logs in and checks if that user has had 3 or more failed login attempts. First, let's discuss the structure of our inputs to build a strategy to develop our program. We have a log file stored in a TXT format that contains one username per line. Each username represents a failed login attempt. So when a user logs in, we want our program to check for their username and count how many times that username is in our log file. If that username is repeated 3 or more times, the program returns an alert. We'll start with code that imports the file of login attempts, splits it, and it stores it into a variable named usernames. Let's try printing the variable usernames to check for its contents. We'll run this. Perfect. This is exactly what we expected. The variable usernames is ready to be used in our algorithm. Now, let's develop a strategy for counting username occurrences in a list. We'll start with the first 8 elements of the usernames list. We notice that there are 2 occurrences of the username ERAAB in the list. But how would we tell Python to count this? We'll implement a for loop that iterates through every element. Let's represent the loop variable with an arrow. We also define a counter variable that starts at 0. So our for loop starts at the username ELARSON. At every element, Python asks, is this element equal to the string ERAAB? If the answer is yes, the counter goes up by 1. If it isn't, then the counter stays the same. Since ELARSON is not the same as ERAAB, the counter remains 0. Then we move on to the next element. We encounter our first occurrence of ERAAB. At this point, the counter increases by 1. As we move to the next element, we find another occurrence of ERAAB. So we increase our counter by 1 again. That means that our counter is now at 2. We will continue this process for the rest of the list. Now that we know the solution, let's talk about how to implement it in Python. Solving the problem in Python will involve a for loop, a counter variable, and an if statement. Let's get back into our code. We'll create a function that counts a user's failed login attempts. First, let's define our function. We'll call it login check. It takes 2 parameters. The first is called login list, These will be used for the list of failed login attempts. The second is called current user. These will be used for the user who logs in. Inside of this function, we start by defining the counter variable and set its value to 0. Now, we start the for loop. We'll use I as our loop variable and iterate through the login list. In other words, as the loop iterates, it would run through all the failed login attempts in the list. Directly inside of the for loop, we start the if statement. The if statement checks if our loop variable is equal to the current user we're searching for. If this condition is true, we want to add 1 to the counter. We're almost done with our algorithm. Now, we just need the final if-else statement to print the alert. If the counter adds up to 3 or more, we need to tell the user that their account is locked, so they can't log in. We'll also type an else statement for users who can log in. Our algorithm is complete. Let's try out our new function on an example username. We can pull out a few of the usernames in the list and try our function on them. Let's use the first name in the list. Let's run the code. According to our code, this user can log in. They have fewer than 3 failed login attempts. Now, let's go back to our user ERAAB. Remember, they had 2 entries in the list of the first 8 names in our failed login attempts. Do you think they'll be able to log in? When we run, we get an account locked message. This means they had 3 or more failed login attempts. Excellent work. You just developed your first security algorithm involving a log. As you grow in your skills, you learn how to make this algorithm more efficient. But this solution works well for now. In this video, we recapped everything we learned so far, from list operations to algorithm development, all the way to file parsing. We did this while building an algorithm we can apply in a security context. As a security analyst, you might be required to read or write code. And one of the biggest challenges is getting it to run and function properly. In fact, fixing complex errors in code can sometimes take up just as much, if not more time, than writing your code. This is why it's important to develop this skill. Now that you learned the basics of coding in Python, it's important to learn how to deal with errors. For that reason, we'll focus on debugging your code. Debugging is the practice of identifying and fixing errors in code. In this video, we'll explore some techniques for this. There are 3 types of errors: syntax errors, logic errors, and exceptions. Syntax errors involve invalid usage of the Python language, such as forgetting to add a colon after a function header. Let's explore this type of error. When we run this code, we get a message that indicates there's a syntax error. Depending on the Python environment, it might also display additional details. We'll typically get information about the error, like its location. These syntax errors are often easy to fix since you can find exactly where the error happened. They are similar to correcting simple grammar mistakes in an email. Since the error message tells us the problem is on the line that defines the function, let's go there. In this case, we can add a colon to the header and resolve our error. When we run it again, there's no longer an error message. This is just one example of a syntax error. Other examples include omitting a parenthesis after a function, misspelling a Python keyword, or not properly closing quotation marks for a string. Next, let's focus on logic errors. Logic errors may not cause error messages. Instead, they produce unintended results. A logic error could be as simple as writing the incorrect text within a print statement, or it might involve something like writing a less than symbol instead of less than or equal to symbol. This changing operator would exclude a value that was needed for the code to work as intended. For example, imagine that you reach out to a response team when the priority level of an issue is less than 3 instead of less than or equal to 3. This means all events classified as priority level 3 could go unnoticed and unresolved. To diagnose a logic error that's difficult to find, one strategy is to use print statements. You'll need to insert print statements throughout your code. The print statements should describe the location in the code. For example, print line 20 or print line 55 inside the conditional. The idea is to use these print statements to identify which sections of the code are functioning properly. When a print statement doesn't print as expected, this helps you identify sections of the code with problems. Another option for identifying logic errors is to use a debugger. A debugger will let you insert breakpoints into your code. Breakpoints allow you to segment your code into sections and run just one portion at a time. Just like with the print statements, running these sections independently can help isolate problems in the code. Okay, let's move on to our last type of error, an exception. Exceptions happen when the program doesn't know how to execute code, even though there are no problems with the syntax. Exceptions occur for a variety of reasons. For example, they can happen when something is mathematically impossible, like asking the code to divide something by 0. Exceptions might also happen when you ask Python to access index values that don't exist, or when Python doesn't recognize variable or function names. Exceptions also may occur when you use an incorrect data type. Let's demonstrate an exception. Let's say you have a variable called myString that contains the word security. Since this string has 8 characters, we can successfully print any index less than 8. Index 0 contains S. Index 1 contains E. And index 2 contains C. But if you try to access the character at index 100, you'll get an error. Let's run this and explore what happens. After it successfully prints the first 3 statements, we get an error message. String index out of range. For exception errors, you can also make use of debuggers and print statements to figure out the potential source of error. Errors and exceptions can be expected when working in Python. The important thing is to know how to deal with them. Hopefully, this video provided some valuable insight about debugging code. This will help ensure that the code that you write is functional. Our coworkers need some help getting their code to work, and we offered to debug their code to make sure it runs smoothly. First, we need to know about the purpose of the code. In this case, the purpose of the code is to parse a single line from a log file and return it. The log file we're using tracks potential issues with software applications. Each line in the log contains the HTTP response status codes, the date, the time, and the application name. When writing this code, our coworkers consider whether all the status codes needed to be parsed. Since 200 signals a successful event, they concluded that lines with this status code shouldn't be parsed. Instead, Python should return a message indicating that parsing wasn't needed. To start the debugging process, let's first run the code to identify what errors appear. Our first error is a syntax error. The error message also tells us the syntax error occurs in a line that defines a function. So let's scroll to that part of the code. As you might recall, these function headers should end with a colon. Let's go ahead and add that to the code. Now the syntax error should go away. So let's run the code again. So now our syntax error is gone, which is good news. But we have another error, a name error. Name error is actually a type of exception, meaning we've written valid syntax, but Python can't process the statement. According to the error, the interpreter doesn't understand the variable application name at the point where it's being added to the parsed line list. Let's examine that section of code. This error means we haven't assigned the variable name properly. So now, let's go back to where it was first assigned and determine what happened. We find that this variable is misspelled. There should be 2 P's in application name, not 1. Let's correct the spelling. Now that we fix it, it should work. So let's run the code. Great. We fixed an error and an exception. And we no longer have any error messages. But this doesn't mean our debugging work is done. Let's make sure the logic of the program works as intended by examining the output. Our output is a parse line. In most cases, this would be what we wanted. But as you might recall, if the status code is 200, our code shouldn't parse the line. Instead, it should print a message that no parsing is needed. And when we call it with a status code of 200, there was a logic error because this message wasn't displayed. So let's go back to the conditional we used to handle a status code of 200 and investigate. To find the source of the issue, let's add print statements. In our print statements, we'll include the line number and a description of the location. We'll add one print statement before the line of code containing return parsed list. We'll add another above the if statement that checks for the 200 status code to determine if it reaches the if statement. And we'll add one more print statement inside the if statement to determine whether the program even enters it. Now, let's run the code and review what gets printed. Only the first print statement printed something. The other 2 print statements after this didn't print. This means the program didn't even enter the if statement. The problem occurred somewhere before the line that returns the parse line variable. Let's investigate. When Python encounters the first return statement, which sends back the parse list, it exits the function. In other words, it returns the list before it even checks for a status code value of 200. To fix this, we must move the if statement checking for the status code somewhere before returns parse line. Let's first delete our print statements. This makes the program more efficient because it doesn't run any unneeded lines of code. Now, let's move the if statement. We'll place it right after the line of code that involves parsing the status code from the line. Let's run our code and confirm that this fixed our issue. Yes, it printed successful event, no parsing needed. Great work, we fixed this logic error. I enjoyed debugging this code with you. I hope this video strengthened your understanding of some helpful debugging strategies and gave you an idea of some errors you might encounter.